Now doing the structural analysis. Okay, preprocessor element type should be beam and it should be 2D. Okay, close. Then going for material prop, adding the material type, structural, linear, elastic, isotropic. Young's modulus should be E 10 to 10 into 10 to power 9, and Poisson ratio should be 0.3. Closing it. Now going for sectioning, beam, common sections. This breadth should be 5, height should be 1. You can take anything. Okay, going for modeling, then create key points in active CS, creating points 1 at 1.1. the x1 and y should be 0 0. Okay, then apply at point 2. X should be 100, y should be 0, and z should be 0. Okay, you can see the 2 points here. Now drawing the line here, straight line. Okay, after that going for the analysis like meshing, mesh tool, select the lines here, set, select this. Okay, going for 100 divisions, apply, and then selecting this for meshing further. Okay, wait, selecting here mesh, pressing OK. You can see the mesh line here. After that going for solution, analysis type, new analysis, static. Okay, defining loads, applying the loads here in structural form, displacement, then going for key points, adding the boundary conditions here. At this point all degree of freedom should be 0, and on this point only u of y is not equals to 0. Other than that all are 0 here. Okay, can see the boundary conditions are now applied. Now applying the force on the node, it should be in middle, right? You can see node number is 50, so it's in the middle, right? Applying here load in f of y direction of -10 Newton. Okay, now applying a UDL, uniform distributed load, over this beam. So it is in the form of pressure, so applying the pressure on beams, and selecting the points are pick all. So it will take all the points on the beam. So the value should be 4 4. You can take anything, it depends upon you and the problem. And now applying it, you can see the forces are applied on the beam. Okay, now going for the analysis, first we have to click on the solve. In current ls, you can see the values are defined here, right? So closing it. For now going on general, prospect, post proc, then going for plot results, contour plot, nodal solution. In this, selecting the D of solution, displacement vector sum, and selecting the last one, deformed shape with undeformed edge. Okay, you can show the variation between those. Okay, now you just need get the bottom view. You can see the deformation of the beam here, right? Now going for the cantilever beam. If you want to do the cantilever beam, in this also you can just going for solution, then apply loads, settings. You need to delete the constraints and the boundary conditions. For that you need to delete loads, all loads and options. Okay, now you can see it's all deleted now. Okay, now applying the boundary conditions again. For that, define loads, apply displacement on key point on this, right? Now here only DOF is 0, means all degree of freedom is 0 here. You know that in cantilever beam one edge is fixed, another is free, so we are not applying anything here. Okay, so just applying the force at the tip, at this tip. So selecting on node, you can see 10 up now, node number 2, right? So applying the force in a forward direction, let's take it should be 15 minus 15. Okay, going for again solve in current ls. Okay, the solution is done. Now going for general prospect, same plot result, contour plot, nodal solution, going for the same things again. You can see the deformation is slightly is very much accurate here. You can see this is the displacement of the beam, right? You can calculate with the formula the actual and the software value. Thank you.